As I said yesterday, we focused on the graphs of square root functions. We looked at the parent function and its key features. We reviewed the transformation rules, and then we looked at transforming some and graphing them and identifying key features. So today we're going to focus more on the equation of square root functions. Okay, so we're going to look at how to solve. So I'm going to show you the algebraic steps for solving square root functions. There's an extra step that we don't always do. I talk about it a lot. I say a way to check your answers. Anytime you solve an equation for a variable, if you want to check your answer, how could you check your answer? Like if I were to solve this and I get what V equals, how do I know if that's actually what V equals? What could I do? Take it and plug it back into the original equation. Okay, and you check and see, does it come out true? Okay, now I talk about that. It's a way to check your work with all your other functions. But when we're dealing with square root functions, it's actually a step we're going to do every time, because you'll see part of the process of solving for a square root function is squaring both sides to get rid of the square root. And that can create, when you do that, when you square both sides, you can create what's called extraneous solutions. Okay, there's solutions that you get that don't actually work. So you have to check the solutions that you get and make sure that they work. Okay, so when we're solving these, we're actually going to show the work for checking for our algebraic steps. All right, so in this first one, your first step is always going to be to isolate the radical, okay? In this case, the square root. Okay, so we're going to isolate the square root. Whatever's under the square root, we want to get it by itself. In this first example, that's already done. The square root of v minus 9 is by itself. There's nothing outside that radical. B, it's already by itself. There's nothing outside that radical over here with it on this side of the equation. I want to show you what I'm talking about here. This plus 2 is outside the radical, right? Y'all agree? Not under it. So it needs to be moved to the other side first. Okay, so you would have to subtract that 2 across before we do anything else. Okay, so I'll go ahead and just show that here and we'll come back to it later. Okay, so now this looks like the setup of examples A and B up here, where you've got this radical isolated. You've got a radical expression on one side and then something on the other. Okay, you can grab that blue paper right there. Try and sit in the same. Oh, Dennis, we did a new seating chart yesterday. Sorry. So if you will move to, yeah, that's good. All right, and then yeah, Parker, just over one. Thank y'all. Okay, sorry, back to what I was saying. So we isolate the square root. If that's already done for you, fantastic. So then the next step after you isolate the square root, step 2, is to square both sides. So we want to get rid of the square root so that, because the variable's under it and we need to solve for that variable. Okay, so when I square both sides, now this is just a number. It's just 5 squared. So I don't need any parentheses or anything. Same thing over here, but sometimes they'll get more complex and you'll have a problem where it's an expression, okay? it may be a binomial or something over here. It's more than just an x. And then you'll have to put parentheses around the entire side to square it. Okay, so we're going to square both sides, and that gets rid of, oops, I did not mean to have my eraser there. Okay, that gets rid of the square and square root. They negate each other, and so we have got v minus 9 equals, and then 5 squared is 25. Okay, so then the next step is to solve. For whatever your variable is. Okay, so in this case, I'm going to move that 9 over by addition. And I get v is 34. Now, here's where that last step comes in, where I want you to check your answers. So I'm going to take that 34 and I'm going to plug it back in for v in the original expression or original equation. And we're going to make sure that this comes out true. So 34 minus 9 is 25. The square root of 25 is indeed 5. So 5 does equal 5. It checks out. That's your answer. That's your solution. Good. So I'm going to move a little bit faster over here. Okay, so the square and square root cancel. I've got w minus 8 equals 49. I'm going to add 8 to both sides. Leaves me with 57. I'm going to check that. (57 minus 8 is 49. Square root of 49 is indeed 7. So 57 is our solution. Okay. All right, so down here, I already showed you isolating the square root. So now we're ready to square both sides. So that leaves us with 5u minus 16 equals 9. And this just says next to it, solving a square root equation with one radical advanced. Those were more basic because those only had, they were ready to be squared on both sides, and then you had one term to move. So pretty straightforward. So this one's a little more complex just because we actually did have something to move to isolate first. Then when we square both sides, it's not just moving a constant to the other side. Now there's a coefficient in front of our variable as well. So we're going to have to get rid of that 5 also. So to get rid of that 5, I'm going to keep green, divide it out. Now I'm going to check and make sure that that works. So 5 times 5 is 25, and 25 minus 16 is 9. So the square root of 9 is 3. 3 plus 2 is indeed 5. It checks out. So 5 is my solution. Cool? Questions so far? Okay. Now, here is one where we're actually maybe going to get some extraneous solution. Those all other ones, those all checked out. So let's see these that are a little more complex. So we've got W on both sides. See here? This one says solving a radical equation that simplifies to a quadratic. Okay, that's because it's going to become a quadratic because the variable is not just under the radical, the variable is also on this side. Now this radical is already isolated, so step 1 is done for us. So we're ready to square both sides. So now I'm squaring a variable over here. So now I've got w squared equals 11w minus 28. Now this is a quadratic because I've got w squared, or you can think of that as x squared, however you want to think of it. If you want to use x's instead, that's fine. But when you've got your variable squared as your highest exponent, you've got a quadratic. Okay, this is what we just got through talking about, quadratics, last unit before the break. So now I'm going to solve this. When I'm solving a quadratic, I need everything to one side. That equal to 0. So I'm going to move that 11w over by subtraction and the 28 over by addition. So this is going to be w squared minus 11w plus 28 equals 0. So then it's a factoring problem. So to factor this, because that a is an understood 1, the only factors of w squared are going to be w times w. I'm just asking myself what multiplies to 28 but adds to negative 11. If you like to show that X method of factoring and put that up here and say, okay, what multiplies to 28 but adds to negative 11, if that's how you like to show your factoring work, you can do that. Okay, but a lot of you will be able to do this in your head and you won't need to do that. So this is the factors of 28 that add to 11 are going to be 4 and 7. Now, we need them to multiply to a positive, but add to a negative. So they're both going to have to be negative. So it's going to be negative 4 and negative 7. Okay, once you've got your factored form, remember this is where we split and solve. So we set each factor equal to 0. And then we solve them. So over here, I would have to add the 4 over, so I get w equals 4. Over here, I would have to add the 7 over, so I get w equals 7. So now I've got 2 solutions to check. So I'm going to check the 4 first. So 4 equals the square root of 11 times 4 minus 28. So 11 times 4 is 44. Minus 28 is 16. So we've got the square root of 16 is 4. So that one checks out. So that's a good solution. And then I'm going to check the 7. So 7 equals the square root of 11 times 7 minus 28. So that's 77 minus 28. That is 49. So the square root of 49 is 7. So in this one, both of them check out. So they are both solutions. Okay, so we actually haven't had one on here where we got an extraneous solution. But I will tell you that does sometimes happen. So you do want to check those solutions and make sure they both work, because sometimes one will work and one will not. And so you only have one solution instead of 2 in those situations. Questions so far? Okay, flip on over to the back and let's take a look here. This is asking us just to isolate one. There's multiple variables here. There's a and a u. In the second one, there's a y and an n. So this is just practicing the steps to isolate a variable, whatever variable you're told to solve for. Okay, so here I want to solve for u. So I just want to get the u by itself. So this is just understanding I need to get rid of the coefficient first with opposite operation. That would be division. So I'd have a over 2 equals the square root of u. And then to get rid of the square root, I would square. Now here's what I was talking about on the front. Sometimes it's more than just a number on the side that you have to square, so you put parentheses around it. That entire side is squared. Not just the a and not just the 2. Both the numerator and denominator get squared. So to simplify that, I could say a squared over 4, because 2 squared is 4. So I've isolated the u. I solved for u. So this is just making sure you understand the steps to solving. And the square and square root canceled out. Okay, so over here, they want you to solve for n. So to get rid of that n, there's nothing outside the radical. So both sides are ready to be squared. So that leaves me with y squared equals n over 9. Then I'm ready to get rid of that denominator of 9. So the opposite of dividing by 9 would be to multiply by 9. So I end up with 9y squared equals n. Okay, so that is just practicing the algebraic steps, making sure you know the order in which you have to do things to solve. And especially here, knowing that when you square both sides, you have to square the entire side, everything over here. Okay, use those parentheses. All right, so this last one is an application. It says we can use the formula. This is why we just practice this for a situation like this. It says we can use the formula R equals the square root of S over 12.6 to relate a ball's surface area, S, in square inches, to its radius, R, in inches. Suppose a ball has a surface area of 365.4 square inches. What is the radius round to the nearest 10? Okay, well, this one, we don't even have to work backwards because the question that they're asking for, they're asking us, what is the radius? That's R. So R is already solved for. So in this one, I don't even have to work backward to find S. If they had given us the radius and asked for the surface area, we would have to do some steps to solve for S. Okay, but we don't have to here. We're plugging in for S. They tell us the surface area here. So we're just going to plug that in and calculate. So R equals the square root 365.4 over 12.6. And you can, of course, use a calculator to do this. Let's pull up Desmos. Okay, remember your square root symbol is here on your keyboard down here. Okay, and then we're dealing with a fraction. It was 365.4 over 12.6. So approximately, it says to round to the nearest tenth. So that's going to be approximately 5.4 when we round to the 10th place, because that 8 will make the 3 round up. And that was in inches. Okay, while I've got Desmos pulled up, I want to show you what you can do in Desmos for these type on the front where you're solving just like quadratics. If you think back, when we were solving quadratics or absolute value, when we are solving for the variable, solving for x, for instance, who remembers what that number represented? What are you solving? What does that number on the graph represent? I think somebody said it. Thank you. It's the x-intercept. So when we're doing all of this solving, this number that we're getting, This is the x-intercept of this graph. Now, in Desmos, when you graph, I'm going to use just example, the first example we did here. There's a couple of things. When I do this square root, and I'm going to use x instead of v, equals 5. It's not going to show me the square root function. For it to show me the graph of this square root function, I need it all to one side set equal to 0 if I want to see the actual graph. So how could I move that 5 to the other side so this was set equal to 0? So I could subtract 5. So instead of having this as equals 5, I'm going to change that to minus 5. And now you can see a square root function appeared on my graph. So I can see the actual graph here, and I'm looking for the x-intercept. There it is, it's 34. Isn't that what we found algebraically? So it is the x-intercept of this function when it's graphed that you're finding. So if you prefer to find this graphically, you can. You can use Desmos. But if you want to see an actual graph, like we were graphing yesterday, of that square root function, it does need to be set equal to 0. Now, let me show you when that was equals 5. It does not show me an accurate graph of the square root function, but what it does show me is a line going through the solution. So I can't click on it and see what it is, but I can zoom in and see what number is that line going through. 34, right? So even if I type it in as is, it's going to show me a line through the solution. So I can straight up see the solution this way. I can see the actual graph if I set it equal to 0 and see the solution that way. Or I can solve algebraically like I've shown you here in our notes. Okay, let's try one of the more complex ones. So this was 5u, and again, I'm going to use x, minus 16 plus 2 equals 5. Okay, we got 5 as the solution. Let's go over here and see. Yep, look at that. A line going through 5. That confirms our solution. Now, if I wanted to see the actual graph of this square root function, this 5 would need to be subtracted to the other side. So I could change that to a minus 5, or I could combine those, plus 2 minus 5 to a minus 3, and it would give me the same thing. But I can see the actual graph now, and I can see that's the x-intercept at 5. Okay, and you can see if I went ahead and combined these like terms and wrote that as minus 3, the graph doesn't change because that's equivalent. Okay, the one that turned into a quadratic, let's try that one. That one was x equals the square root of 11x minus 28. Notice there's 2 lines because there's 2 solutions. They're at 4 and 7. That confirms what we got here algebraically. So you can use this as a way to check. If you prefer to do the algebraic method, you can check with Desmos. Okay, if I wanted this all to one side, I could just subtract this entire square root over to the left, or I could subtract this x over to the right. If I subtracted the x over to the right, it would be outside the radical, like that, minus x, and I wouldn't have the equals x anymore. And then I can see this graph, and I can still see those solutions are at 4 and 7. Or I can type it in as the quadratic form that we came up with. In this step right here, we said x squared minus 11x plus 28, 4 and 7. Get the same thing. This is the more accurate graph because you have squared both sides and have it set up as a quadratic. but doing it the other way still showed you the same zeros. Do y'all get how to use Desmos? Do y'all understand the different ways that you can find your solutions in Desmos? Okay. So y'all are free. We've got like 17, 18 minutes for y'all to practice. There is a practice assignment in Delta Math. So you should see, let me get a sample student page so you can show you what you should see. You should see 2 assignments. You should see yesterday's. If you have not finished it, it would still show up here. If you have finished it, it's moved to the completed tab and you're good. Okay, but you have yesterday's that is due tomorrow. And then you have today's, which is not due till Sunday. Because remember, and those of you who are new this semester, when we have our assignments assigned, our practice for the day, I give y'all 2 school days till it's due. So technically you have 3 nights. You have tonight, tomorrow night, and then the second night. So like yesterday was Tuesday. You had Tuesday night, you have tonight, and then you have Thursday night till midnight. So technically you usually get 3 nights to complete the assignment. But when that lands on a Friday, like today's will, because it's assigned on a Wednesday, 2 school days later is Friday, I'm not going to be checking this weekend. So instead of having it due Friday night before midnight, I just extend it to Sunday. So you've got plenty of time to complete this one. I would suggest finishing up yesterday's first since it is due tomorrow. If you have completed that, or when you do complete that, then I would start on today's practice. Okay. Oh, hang on one sec. Just one more reminder. Yesterday's assignment was all pulled from Delta Math. These come from the Delta Math bank of questions. So when you get one wrong, you can try another one. Okay, you can keep trying and getting that full credit. Okay, today's was questions. Remember when they look like this, they're input from like a paper assignment we had, and we just input them into Delta Math to make it easier. But this means that it's not going to generate a new question if you get it wrong. Now, I'm going to give you 3 attempts at it. It'll give you the warning, that's not right, go back and try again. That's not right, go back and try again. But if you still get it wrong on the 3rd attempt, it's just wrong and you lose the points. Okay, so just remember, the ones like this are a slightly different grading because you don't get unlimited problems generated to keep trying. Okay, so be careful. Don't squander those attempts. Okay, take your time. If you're getting it wrong and you don't know why, ask for help before you waste that last attempt.